Okay, so it's 2.8.3. But I want to start by looking back before we get into the new stuff. The new stuff is about rational equations like this, and setting those greater than or equal to 0. But before we get into that, I'd like to talk about the old stuff. We just did this yesterday, and I think it's really powerful to be able to sketch something like this, to be able to tell where it's greater than 0. So would you make a little sketch? And I mean the graph. I mean, like, make a little sketch of the graph. Like, let's say it looks like this, and it goes through here and bounces off of there, or whatever it does. And then you got to look at it and say, where is it greater than 0? So in this case, you'd say there. Well, anyway, make me a sketch like that, and see if you can solve this problem. I'm going to pause for a second while you give that a shot. Okay, now I'm changing the answer just a little bit. I want you to say greater than or equal to. Nope. That's the common mistake. Nope. Nope. Let me make sure. Yup. Nope. You're close. No, you're close, but you're on the right track. You've got it. You've got it. You need to reverse yours because they need to be in order from smallest to big. Other than that, you had it. Yes, that's what I was looking for. Yes, yes. 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 Yes, sir. Yes, ma'am. You forgot something. Okay, so here's what I was getting at on that one. I knew a lot of people make the mistake, and they did. Here's -3, and it's bouncing there, and here's +4, and it's cutting through there. Notice the lead coefficient of this thing is positive because it's an x squared, and an x makes an x to the third. So if it's y equals x to the third, it must be going up on the right. So then logically, it's cutting through this, it must cut through, and then bounce off of this and go down. And everybody says that, oh yeah, it's positive there from 4 to infinity, and then they just change this to a bracket 4 to infinity. But what would they be forgetting when they do that? That all of a sudden this one works, and then -3 is in the answer, and I recommend you put it in brackets, union. Because if you had it in parentheses, you'd be saying -3 is excluded specifically, and that's not what you mean. All right, good. That's just a reminder of yesterday. Here's one that's a little more esoteric. I shouldn't use the word. It's more, let's see, absolute value of x -3, of a thinking question than a actually graph it and figure it out kind of thing. So you got to think it through and say, okay, is there any way to make that first parenthesis equal 0? Is there any way to make that second parenthesis equal 0? Is there any way to make that ever come out negative? Is there ever a way that these could come out negative? So what's the answer? Is there anything that would work? So 3 works. I'm asking the question in a dumb way on purpose. Is there anything that would work? Yeah, everything works. The answer is all reals. Why? Because this part is always going to come out positive. If you haven't contemplated it deep enough, if you throw in anything you want in there, there's no way you're ever going to make this thing come out to a negative number. That can't be negative. So therefore, whatever it is going to get added to 3. It's only going to get bigger, so it's only going to be positive. And this here, it's absolute value, which makes it positive. And then it's squared. It's like double insurance that thing's got to be positive. Okay, so this is always going to be positive. If it's always a positive times positive, won't it always be bigger than or equal to 0? Okay, now how about if I change one little thing? Just greater than 0. Well, it almost always works, but tell me what you think the answer is now. Turn it my way when you've got it. I'll tell you if you're right or not. That works. kind of missing the... You're right that there's one number that doesn't work, but that's not the number. Got a little dyslexia going on there. Reverse those two, and then you'll have it. Yup. You're saying x is 3, but it is a real number. I think you're on the right track, but yes. 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 Okay, except if you have to have... There you go. Now you got it. Good. 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 It's not negative 3, though. Pretty sure it's just plain old 3. Yup. Yup. Okay. So the point is that something makes it 0. It's always positive unless you made it 0. And how could I make it 0? If I stuck in x equals 3. That would be the one way I could make it 0. And then that wouldn't be greater than 0. All right, so the process on this, instead of just saying, think it through, you're really supposed to find the zeros and you put them on a number line. This one has a 0. The 0 is 3. So I put a 3 on the number line, and I say it can't be that. Because if it was 0, it wouldn't be greater than 0. And everything else works. So then that's negative infinity to 3. Union with 3 to infinity. All right. So now let's talk about the new thing for today. I'm going to back up to that first slide, which is right here. What's different about this? We still have zeros. We still have zeros. If we didn't have this denominator here, wouldn't it be identical to what it used to be? Aren't these exactly what we were just doing? And the important spots were negative 3 and positive 4, right? Okay, so we just do it like that, except we also have to worry about the denominator, and those are important spots. So the pain in the neck about this kind is that there's a couple things, okay? First of all, negative 3 is one of your answers. That's for this one. Positive 4 is one of your answers. That's for that one. This one's negative 5. And this one is positive 6. All right, those are all important spots. Do you remember before we'd look at this and we'd say, oh, so it's greater than, so they're empty circles. And what if I had this as a greater than or equal to? Then I'd say, oh, they're all filled in circles. But not anymore. Why? If I change the problem to say greater than or equal to, in other words, it can equal 0, why are some of these still not going to work? Yes. Yeah. If they're on the bottom, then if I put in like negative 5, for instance, you might think it's going to work, but it can't be greater than or equal to 0 because it won't exist. Those things are not zeros. They are undefined. So in calc, they teach you to do this. And we're going to ask you to do this in Precalc as well. Prepare for calc. This is not a 0. It's a spot where it's undefined. So is this. Put a U above them, and that will hopefully remind you to never use those points. You never fill in those circles, even if it says greater than or equal to. The other spots are zeros, and you should put a Z above them. Do you get it? The ones that are on top are Z's. The ones that are on the bottom are U's. U means they will make it undefined. Z means it is a 0. It will make the function equal 0. Okay? So now, of these 4 things, the U's or the Z's, which ones are still going to actually, if I plugged them in, would make it work as opposed to crash? The Z's are the ones that make it work. So I should fill those in because it says or equal to. Okay? And now, do I have to test around all these spots? Yep. And since that's the thing that kids generally have been pretty bad at on tests, that's where I would expect pretty much all the mistakes to happen, is kids will test them wrong. And I think that's just because it's detail work. And most people would say that high school students are not great at being really careful. It's not like supposed to be a strength of people at your age, being careful. Does it mean it can't happen? No. If you're careful, if you're really careful about being careful, but that doesn't come naturally to most teenagers. So you got to fight that urge to just get it over with quickly and get it done, because If you make one little mistake and you think it works in here where it really doesn't work, whole thing's wrong. You've got to be really careful. So would you please test all of these 1, 2, 3, 4, 5 intervals, and let's see how many of you can be perfect and know where it works and where it doesn't. To test the intervals on this puppy, that means take a number like 7, stick it into your function, and figure out whether it works or not. Just a side note, I think some of you are doing it the slow way, and I want to show you the fast way versus the slow way. I hope you all use 0 in here, just because it's such an easy number to test. Okay, so I'm going to test 0 in there. Put a 0 here, 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 and here. I do not need to actually get the number answer. Because I'm comparing with 0, all I care is it positive or is it negative? So if I put in 0, I can say it's positive, negative, over positive, negative, plus, minus, over plus, minus. If I have a positive and negative, or a positive and a negative, basically I have two negatives, which makes it positive, right? So if the whole thing comes out positive, is it greater than 0 then? Yeah. See how I didn't need to exactly even know what the answer was when I stuck in 0? I just care that the answer came out positive. When you look at the answer key that's worked out probably by Mrs. Richens, she's going to have little pluses and minuses on top of each other. This is what she's doing. She's not sticking in the number 0 and getting exactly 3 times exactly negative 4. She is figuring out it's, oh, so this one's going to be positive when I put in 0 here. This one will come out negative when I put in 0 there. Okay, so that's the fast way. The slow way is we actually calculate it out and get a numerical answer and see if that is greater than 0. That works. The positive negative thing, way faster. I think you'd like it better. I think it'd be more accurate. All right, so I gave you one of the 5 intervals. How many of you are done with all 5 now? You know where it works and where it doesn't. Since it's only 4 people, I'm going to pause for a second, give you a moment to work. Negative 6 or 7, what did you think the first spot was? Did it work or not? You said it did work, like this. How many of you agreed with him? All right, good. We'll let the majority win on this one. All right, then how about negative 4? When you put in negative 4, I hope you thought something like this. This will be negative, this will be negative, negative, and positive. One little positive in there. So that means 3 negatives. That means the answer is negative. It's negative things bigger than 0. I hope you said it did not work. Right? Pretty good. Then we go over between the 4 and the 6. What do you say about that one? Said it didn't work. All right. And then how about between the 6 and infinity? And it did work. All right. How many of you agree with his assessment? Okay. All right. I'm just going to check that 7 quickly. It's the most fun one. And I bet you'll understand when I show you in a second. If you put in a big positive number, do you get how it's going to make that positive? And if it's big enough, which it always will be, it'll make that positive, it'll make that positive, it'll make that positive. Everything's positive. So it's really easy to do. So it's just positive is greater than 0. Yeah, it is. So, all right. So then, final answer is negative. Infinity to negative 5. And does negative 5 work? No. But negative 3 does work. 2, 4 does work. Union with 6 does not work. All the way to infinity. There we go. And again, details. All it would take is one parenthesis where it should be a bracket, and it's wrong. All right, so the moral of the story is, in the past, we had this. Now, we just added another layer, which means there's more zeros. Here's the other layer. And I did something on purpose here to show you off just a smidge. What does this one have in it that the other one does? Oh, very good. got a hole here at 3. That means if you looked at a picture of the function, it would look kind of like this. Except at 3, there'd be this little empty spot, like going along, and then, oop, doesn't work at 3. Okay. Well, how does that, what does that do in our answers we were just doing? Well, 3 is an important spot still. Think about it. Can 3 ever work then if it's a hole? No. It would be just like a Z or a U, except what letter would this one be? An H for a hole. Okay? So it's never going to work at 3. It's just like it's kind of like more like a U than it is like a Z. Because U's are undefined. These are kind of like undefined, it's just that they're a different way. Instead of turning into an asymptote, they turn into a hole. Alright. So, I still have -5 on my list. Still have -7 on my list for this one. And then I would say to myself, okay, greater than, that means that even this is undefined, it could never have worked. But the -5 doesn't work either, because it doesn't have an or equal to. Right? So, empty spots, and then you'd have to check the intervals here, and here, and here, and here. Alright, that's a review of how to do 2.8.3. And you now have an assignment. I'm just going to have you skip one problem. You're going to skip number 7. It is otherwise a pretty short assignment, and you have a boatload of time. Use it well, and you go home with no homework for the weekend. Last thought, top 20s. Some of you guys have a top 20 score in there that's hurting your grade. That's really ridiculous since it has unlimited retakes, and it's on all basics. So I strongly encourage you to look at your top 20 score that's in the gradebook, and if it's not some sort of a B or an A at least, it's in the C's, Pete's sakes, take it over again and study it a little bit over break. You could do that for 5 minutes a day, and it would make a big difference in second semester too. There's a reason I'm making you memorize, or not memorize, learn all of those basic skills. It's like if you don't get fractions, when we get to trig and we're doing this, how are you going to get common denominator when you don't even know how to find a common denominator of simple numbers? And you have to get a common denominator for these two, and then add them together. Yes, sir. Yeah, I'm showing people, I guess, that they need to know their top 20 skills, and over break time would be a great time to practice. Okay, you can go to my website if you want to practice them. All right, that's all I have for you for today.